Hello dear students. So today's session is very interesting and very simple and also important for your both IP exams, that is your board exams, and also for NEET, JEE and EPSET exams. Okay, let us discuss this in very simple and easiest way possible. Okay, you just stay with me for next 10 minutes so that you can completely get an idea on balancing of redox reactions. So first of all, let me show you a question from previous year NEET exam. Okay, look at this question first. Yeah, so this is how they will be giving a question. So now read the question once. For the redox reaction, they are saying this reaction is a redox reaction. Okay, the coefficients of the reactants for the balanced equation are. Okay, now if you remember, I have started discussing about this redox reaction in the before last 4 sessions, I hope. Okay, so if you observe there, in that session I explained about what do we mean by oxidation and reduction and calculation of oxidation number for different compounds. Okay, this discussion is already done. Now using the same concept in the questions, we are going to solve this. And once again, one small suggestion is, if you haven't watched that session, please go and watch it. Okay, so once after completing that, you come back and see this session. Okay, right, let us discuss about this balancing of redox reaction. Okay, so now in the question, as I mentioned, they will be giving an equation like this and asking us to balance this. So what do we mean by balance first? Look at this. How many carbon atoms you are seeing this side? See, this is C2O4, means 2 carbons are there at this left hand side, and the right hand side it is 1 carbon atom only. It means atoms are not balanced here, right now. So there should be same number of carbon atoms reactant side and product side. Like that, you take any atom, that should be equal in both of the sides. If one manganese atom is there here, there should be 1. Ila ప్రతి atom కూడా ఈక్వల్గా ఉండాలి, రియాక్టెంట్ సైడ్ ప్రొడక్ట్ సైడ్. ఇప్పుడు దాన్ని ఎలా బ్యాలెన్స్ చేస్తాం అనేది మన డిస్కషన్. ఓకే, సో ఆల్రెడీ మెన్షన్ దీస్ ఆర్ రిడాక్స్ రియాక్షన్స్. రిడాక్స్ రియాక్షన్స్ అంటే ఏంటి? వాట్ డు వి మీన్ బై రిడాక్స్ రియాక్షన్? సో ఇన్ ఏ రియాక్షన్ both oxidation and reduction takes place. Those reactions are called as redox reaction. Now identify what is the reduction of and oxidation of the given equation. Look at this. What is the oxidation state of manganese in this ion? So calculate it. So how can I calculate that? First of all, write the skeletal equation. Means writing the equation first. And next, first step is writing the skeletal equation. That is done, written. Second step is you just follow these steps to balance it. It is very simple. Listen to me. I will explain it very clearly without any confusions. Okay. So first find its oxidation state. How to find oxidation states? In the last session I discussed. Again I am explaining here. See, for manganese atom, I need to calculate its oxidation state. Therefore, for manganese it is X. I want to find this X value. Okay. How many oxygens are there? 4. Each oxygen atom oxidation state should be -2. And what is the charge present on this ion? It is -1. So X is going to be -1 plus 8. That is, X will be taken as plus 7. So what is the oxidation state of manganese here? Plus 7. Okay, like that. So in this case, the carbon, if you observe, there are 2 carbons. Now what is the oxidation state of each carbon? We need to calculate. So what we are going to do? Yes, take 2, multiply it with X, because the carbon oxidation state only I want to find. Consider the element as X here, plus 4 oxygens are there. Each oxygen will be -2. Okay, and overall charge present is -2. Now if you do this, -8, if you send this side, plus 8 -2 plus 6, and this 2 if I send that side, 6 by 2 is 3. So plus 3 is the oxidation state of carbon in this case. Okay, like this we need to assign the oxidation state for the species undergoing oxidation and reduction. See, a +7 manganese ion converting into +2. It means number is increased or decreased. plus 7 converted into plus 2 na, number decreased, number reduced, reduction in number. So you can say this process as reduction. What is that process? Reduction. Okay. So in the same way, if you observe carbon here, it is plus 3 converted into plus 4. So what is this process? Just say plus 3 converted into plus 4 means you can say it as oxidation. What is that? Oxidation. Okay. Like this, identify reduction half, identify oxidation half. Once after knowing this, we can make it simple. So what is the second step I told you? Assign oxidation states. Means find the oxidation state and assign them to the species, elements. Okay, like this, assigning the oxidation number. So the third step is, see, I told this as a reduction, that as an oxidation. In reduction, how many electrons involved? Plus 7 converted into plus 2. అంటే నెంబర్ రెడ్యూస్ అయింది కదా. హౌ దట్ నెంబర్ ఈస్ రెడ్యూస్డ్? సి ఏ పాజిటివ్ చార్జ్ ఈస్ రెడ్యూస్డ్ మీన్స్ వీ హ్యావ్ యాడెడ్ సమ్ నెగటివ్ చార్జెస్. దోస్ ఆర్ నథింగ్ బట్ ఎలక్ట్రాన్స్. హౌ మెనీ ఎలక్ట్రాన్స్ వీ యాడెడ్? plus 7 converted into plus 2 means by gaining 5 electrons. Each electron is minus 1 charge. Like that, if I add 5 electrons, so it means minus 5 plus 7. How much it is? Plus 2. That's why here it is plus 2. So by gaining 5 electrons, manganese is undergoing reduction here. In the same way, the plus 3 converted into plus 4 means 1 electron is lost. See, charge increasing means you should say it is an oxidation. How much increased? 1 increased. So 1 electron for 1 carbon. Like that, how many are there? 2 carbons are there. So 1 into 2. You can write 2 electrons are involved. Yeah, it is simple. So in oxidation, 2 electrons lost. In reduction, 5 electrons gained. Okay. Now remember, in any redox reactions, number of electrons lost should be equals to number of electrons gained. Where it is lost? In oxidation. Number of electrons lost in oxidation should be equals to number of electrons gained in reduction. Like this, we should consider. Number of electrons lost in oxidation should be equals to number of electrons gained in reduction. This is the thing we need to consider. See, now how many electrons gained in reduction? It is 5. But here last is only 2. These numbers are not equal. No? We need to equalize them. How can we make them equal or equalize them? Yeah, it is very simple. Multiply with suitable integers. What do we mean by suitable integers? See, I need to make these two numbers the same. Now what I am doing is, here it is 2, here it is 5. So what I am doing? I am multiplying this number with 2 and this number with 5. So overall how much? So 5 2s are 10. Here also 10 electrons. 2 5s are 10. Here also 10 electrons. Okay? It is very simple. What I did? This reduction equation is multiplied with number 2 and the oxidation number is multiplied with 5, so that number of electrons in oxidation reduction are equal, that is 10 electrons. Okay, so this is the third step. Okay, so you need to make them number of electron lost in oxidation equals to number of electrons gained in reduction. See, for making this process, what is the number I used here? 2. So this multiply this complete equation with 2. Complete equation means the reduction equation. What is the reduction species involved here? 2MnO4 minus plus C2O4. Let us write C2O4 2 minus as it is, H plus converted into Mn plus 2 now. How many? We multiplied with 2 now. So you can write 2Mn plus 2. Why only this equation? This species here, this species and this species are only two things involved in the reduction. That's why I multiplied both of them with 2. Okay. Whereas this one, oxalate ion, involved in oxidation. Oxidation equation is multiplied with 5 now. Yeah. So you can write here 5 C2O4 plus CO2 is how much? Here 1 CO2 is there, that is also involved in oxidation. So you can write 5 CO2. Okay, and the remaining species as it is, like H2O as it is. Okay, that's it. Now if you observe, the number of electrons gained and lost are equal. This is fine. So just check whether equation is balanced. No, not yet balanced. Okay, right. The next step, fourth step is balance all the atoms other than oxygen and hydrogen. It means first we need to balance these atoms, all atoms other than oxygen and hydrogen. Oxygen, hydrogen keep aside, we will balance them later. First balances other than those two atoms. Here how many manganese we have? 2. Just check, here also manganese are 2. So manganese atoms are balanced. Okay, ions are balanced. Next, carbons, if you find here, see 5 2s are 10 carbons are there, but here I have only 5 carbons. So just remove this, simply add 10 there, I mean just put 10 there, that's it. This is balanced. After that, count now, 5 2s are 10 carbons, done. Okay, now after balancing this, it is over. Now balance oxygens. Now balance oxygen atoms by adding water molecules, water to deficient side of oxygen, deficient side of oxygen atoms. So wherever oxygens are less, that side you add water and balance the equation. Now what we are doing? Now we are balancing oxygen atoms. How can we balance oxygen atoms? Wherever there is deficiency in oxygen, that side you add water. Okay. Now look at these ones. Here how many oxygens are there? See, 4 2s are 8. 8 oxygens here, 8 oxygens here, and 4 5s are 4 2s are 8 here, 5 4s are 20. So total 28 oxygens are there this side, reactant side, left hand side. Right hand side, if you observe, there is only 20 oxygens are there. Along with this it becomes 21. Now which side is deficient? Product side is deficient. How many deficient? Here 28 means, here 21 means, still 7 is required. So you add 7 water molecules here. So 7 plus this one. So total 8 water molecules product side. Okay. So totally how much it becomes? 20 plus 8, 28 oxygen atoms both sides. Okay. Like this you can balance oxygen atoms also. Done. Next, who is left here? We are left with hydrogen atoms only. Now balance hydrogen atoms by adding H plus ions to the deficient side. Wherever there is deficiency in hydrogen, you just add hydrogen to that side. So look at this, we have one H plus ion this side. Here how many hydrogens are there? 8 2s are 16. So 16 hydrogens this side, there is only one hydrogen this side. So 15 more should be added here. So you just make it as 16. Okay. So it becomes 2MnO4 minus plus 5C2O4 2 minus plus 16H plus gives rise to 2Mn plus 2 plus 10CO2 plus 8H2. Okay, that's it. Now check, everything is balanced. How many manganese? 2. There are also 2. How many oxygens? 20 plus 8, 28. There are also 28. Next, carbons 10, 10. Next, hydrogens 16, 16. Everything is balanced. Okay. So this is your final conclusion, final answer of this discussion. Okay. Now look at this balanced equation and try to answer me these questions. Look at this. For manganese, what is the number we have seen? 2. Okay. For oxalate we have seen 5. So 2, 5, and for H plus ions we have seen it as 16 in our final equation here. 2, 5, 16. It means our answer will be 2, 5, 16, second option. Okay. Even they ask for product side also. What are the coefficients we have seen? Here also it is 2, and this side we have seen it as 10, and here it is 18. So these are the coefficients of products. So how simple it is? I think you might feel it is lengthy, but once if you practice it for 2 more questions, you are going to make the answer within 1 minute, because it is very simple once you get practice to it. Okay, right. So now as a practice purpose, I will be giving you one question. You need to balance it and mention your answer in the comment box. Okay, yeah. So just look at this question. Look at this question. Everything is same except this chromate. There I used permanganate ion, potassium permanganate, like permanganate ion. Here I am giving you dichromate ion. Okay, so right. So this is also in acidic medium only. Balance in the same way, follow same steps that we used there. First step is what? Writing the equation. Yes, written. You just write that in the white paper once. After writing that, next, that equation is called skeletal equation. Remember again, this is equally important for your board exams in class 11th, mean first year intermediate for 4 months. So it is easy, very easy. You can do it. Okay, right. After that, assigning their oxidation state. How much oxidation state? If you calculate, you are going to get this as +6. Once you again try it, practice it, calculate whether, verify whether this +6 is correct or not. For carbon here it is +3. Again you cross check this. Again here it is +3 correct only. Here it is going to be +4. Like this you need to assign the numbers first, oxidation numbers. Now identify oxidation reaction, reduction reaction. Chromium is converted into +3. So this is reduction because +6 reduced to +3. Reduction. Carbon is converted from +3 to +4. So this is oxidation. Okay. Now how many electrons involved in reduction? See, there are 2 chromiums. Each chromium is converting from +6 to +3, means 6 electrons are involved. In the same way, here 2 carbons. Each carbon is +3 oxidation state, converting it to +4, means 1 electron. So here in oxidation 2 electrons involving, reduction 6 electrons involving. Are these numbers the same? No, these are not same. Now what we need to do? We need to multiply these numbers to make it equal, because in a redox reaction, number of electrons lost in oxidation should be equals to number of electrons gained in reduction. Okay, in order to making that, so I can multiply these 2 electrons with number 3. It means this equation with number 3, so that it also becomes 6, and this 6 equation with 1. It means I am keeping it as such. Okay, now write that new equation. What we are going to get? 1 Cr2O7 2 minus plus C2O4 2 minus, giving H plus. In acidic medium it means Cr plus 3 plus CO2. Now what I told you, this dichromate equation is multiplied with 1. Next, this oxalate equation is multiplied with 3. That oxidation reaction is multiplied with 3. So 3, and carbon here it is also 3. Okay. Now electrons are balanced. Now balance all atoms other than oxygen and hydrogen. See how many chromiums are there? 2. This side only 1. What I should do? Just put here 2, that's it. Next, after doing that, how many carbons are there? 2 3s are 6. Same steps we followed in the previous question also. So in the same way, you pause the video and first you do it on your own. Okay, then you can watch. So 2 3s are 6. So here only 3 are there. So what you need to do? Make it 6. That's it. Done. After that, how many oxygens are there? 7 oxygens. This one is how much? 4 3s are 12. Okay. So this is 19. Okay, that's it. 7 plus 12. This side how many we have? Check once. Check once. 6 CO2 are there. It means you can write it as 12. Okay. Yeah. So 12 oxygens are there. Just a minute. I will be checking the question whether everything is right or not. Yeah, that's it. This is how they have provided. Now check once again. Here 19, there it is 12. So where do we have more number of oxygens? This side we have more number of oxygens. Then what I should do? To that deficient side, the oxygens which are deficient, that side I should need to add water. How many waters I should add? Here it is 19, there is only 12. So still how many required? 7 are required. So I can add 7 water molecules here. I am adding 7 water molecules here, so that number of oxygen atoms here 19, there also it becomes 19. Done. What about next? H plus ions, hydrogens. How many are there? Product side there is 7 to the 14 are there. The reactant side also it should be 14. So here this H plus ion is given now. So you can write it like this, 14 H plus. That's it. So this is your final equation which is balanced one. Just cross check and verify with your answer whether both of them are same or not. Okay, and if there is any confusion in the discussion, please write in the comment box. I will be explaining them in the upcoming session. Okay, so thanks for watching. Stay connected with our NEET World YouTube channel. Thank you.